Okay, in this part of the lesson, we're going to be working with classifying triangles according to their angle measures as well as their side lengths. So the first thing you have to understand is when you are identifying triangles according to their angle measures, the largest angle of the triangle names the triangle. Every triangle will have acute angles. That does not mean that it's an acute triangle. You go with your largest measure. Okay, on all of these that are shown, we don't have any measures actually given, so we don't know if it's a 60 or a 65 or a 55-degree angle measure, but we can tell by looking. So when I look at this first triangle, largest angle looks like this one right here. What type of an angle is that? Well, it's acute. It's less than 90 degrees. It's smaller than a corner, in other words. So that would be considered an acute triangle. Okay, so when I look at this second triangle, my obtuse triangle, I'm going to start by looking for the largest angle, the widest opening angle, which is right here. That is considered obtuse, so therefore this is called an obtuse triangle. It'll have one obtuse, the rest are going to be acute. But remember, we only name a triangle according to its longest or largest angle measure. Here, largest angle right there, 90 degrees. So that would be considered a right angle or a right triangle. You will have some special circumstances, and this is the only example when you're going according to angle measure. If all of the angles are equal, it is considered equiangular. So that first part of the word there looks like the word equal, so it's equiangular, okay? So that's naming according to angles. You always go with the largest angle measure. When we classify according to sides, they will use some markings sometimes, otherwise they might actually write the side measurements off to the side. So congruent sides means they have the same length. This is what they are going to use to show they're the same length. They're going to use little markings that are the same. Okay, so we will be working with scalene, isosceles, equilateral, and then there's also another one that's called equilateral. These are the three that we'll be using. So scalene means no sides are equal. So you notice there's no markings on any of the sides. That's considered scalene. Isosceles, the way that I remember the difference between isosceles and scalene is isosceles, isolated, one person by themselves, one side by itself, one side that's different. So isolated. So isosceles triangles have one side that's different. Equilateral, once again, we have the first part of the equal in there. So equilateral means all sides are equal, okay? Scalene and isosceles are usually the ones that gets mixed up the most. So I just remember iso means one, so one side that's different in length. All right, so let's go ahead and try identifying these according to both their angles as well as their sides. So I will always give you the wording. Even when you assess, I will give you the wording. So we're going to start off with looking at these angle measures. Well, first of all, this is how they're going to mark angle measures. If they're marked the same, it means they're all the same. So according to angles, it's equiangular. So I'm just going to put an E for equiangular. And according to sides, well, they're all marked with the same marking. That means they're all the same length. If this was 3 centimeters, then all of these are 3 centimeters. Okay, we don't know that. I'm just using that as an example. So this would be considered equilateral. I'm just going to use an E for that. Now, if you want to write out the whole word, that's fine. Okay, just for sake of time, I'm going to be circling up above what they are and then just doing the abbreviation. Okay, so let's try, whoops, I'm going to leave that one. Let's try this one. So here I have, these are the same measure of angle. I don't know what it is, but those are my largest angles too. This one looks smaller, more closed. So those are all still, these two, the biggest, are still acute angles. So this would be an acute triangle. There are 2 sides that are the same. Notice we also had 2 angles that were the same. And yes, that works every time 2 sides are equal. You're going to have 2 angles that are equal. So if those 2 sides are the same, that means there is one that is isolated or different. So it would be isosceles. So we would have an acute triangle, also isosceles. So you're going to have 2 names for every one according to its angle measure and its side lengths. All right, let's try this one. So here they're actually giving us dimensions. So we're going to look for the largest number, which is right here. So is that acute, right, or obtuse? Well, that would be obtuse. So it's an obtuse triangle. And then according to its sides, well, the one thing we have to understand is they didn't put any markings here. If all of your angles are different, notice how none of these are the same, then that means all of the side lengths are different. Even though these two right here might look like maybe they're about the same length, they're not. Okay, all of our angles are different. That means all of our sides are different. So the one that has all sides different is scalene. Okay, so we have an obtuse scalene triangle there. All right, so I'm going to slide one out. I want you guys to try naming it according to its angle measure as well as its side lengths. Okay, so we have a right angle, so it's a right triangle. We also have two sides that are the same, which is isolating one side being different, so it's an isosceles triangle.